So hello and welcome. Let's look at question 1.2, and this is a question that deals with equations with fractions, right? So I'm just going to list the equation over there. It's 1 over 2x plus x over x plus 1 is equal to 5x plus 1 all over 4 into x plus 1. Okay, so the moment we have what we call an equation, right? So I've got the equal to sign over there, so that's clearly an equation. When I have an equation, I can clearly see that, okay, I've got fractions involved. I'm trying to work towards either quadratic or something that doesn't have fractions. Now, to get rid of the fractions, I apply the LCD, right? And so I'm going to put the LCD over there in orange. And my LCD would look like the 2x, right? First I'm going to factor this 4 and make that 2 times 2x. 2 times 2. So I'm going to have I'm going to take this x plus 1. I'm going to take that 2x and I'm going to break this down. I'm going to change the sum a little bit and I'm going to call that 2 times 2, right? So I didn't really change anything. If I make that, let's put it in blue to show that we've actually made some changes, but I didn't change the value of it, so that's 2 times 2. Okay, so I'm going to start with the highest common multiple of that, and I'm going to say my LCD is going to be the x plus 1, right, which I have already, and then I'm going to multiply that by 2 times 2, which is going to be 4, okay, and then I'm going to multiply that by, so I've got x plus 1, I've got 2 and 2, that's fine, right, and I need to still include this x. I'm going to include the x over there. So that's my LCD, right? If you've included the 2 and 2 and 2 again, then you've actually gone higher than the least common multiple, okay? Which is definitely not going to be the least common denominator, but when you multiply it out, you should still get the same answer. Okay, so let's see when we apply this what actually happens. I'm going to do our solution here in blue. I take the first term and when I multiply the first term with this, I get the x cancels with that x over there. Okay, I'm left with 4 divided by 2, which gives me just 2. Because if you look at this, remember this is 2 multiplied by 2, so one of that 2 is cancelled out with that, and I'm left with this 2. So that's going to be simply 2. That cancels, I'm left with that one, and the x plus 1. So 2 into x plus 1. That's applying it to the first one. When I apply it to the second one, this x plus 1 linear factor falls away, the x falls away, one of the 2's falls away, right? I'm talking nonsense, people. What I meant to say is the x plus 1 and x plus 1 falls away, and I'm left with 4x multiplied by that x. So it's plus x, right? That x, and now multiplied by 4x is going to be 4x squared. And then I put down my equal to sign. The 2 and the 2, or the 4 that I have over there, falls away, the x plus 1 falls away, and I'm left with 5x plus 1 multiplied with what's left over here of the LCD. That's just going to be x. Okay, the rest is fairly simple algebra. That's going to be 5x squared plus x. This is going to be 2x plus 2 plus 4x squared. All you need to do at this point is get all your x's on one side and work towards 0. I can clearly see 4x squared and 5x squared leaves me with just an x squared on this side. This 2x I get rid of with this x, and that's going to give me the following. 1x left over here, which I take over, becomes negative x. And then finally, I'm left with this 2. Remember, we've addressed this 4x squared and the 5x squared, which resulted in this. This 2, it's on this side, so I'm going to take it over, it becomes negative 2, and then I'm left with the 0 over there. Now, one of the things that I left out before we continue further here is this is an LCD, but you notice that these are fractions, and when I put in x cannot equal to negative 1 because that is a restriction, and then on the other side, x cannot equal to 0, because if I put 0 in there, then it's also going to be undefined. So when I solve this thing over here, I also need to check which values are consistent with the LCD or consistent with the equation. So I'm going to factor that, and I've got factors of 2. I subtract to give me a 1 is 2 and 1, x and x, negative 2, positive 1, and therefore my solution over here is x is equal to 2 or x is equal to negative 1. But clearly you know that x cannot equal to negative 1, so we're going to put a big sign through that which says x does not equal to negative 1. So that's your solution to 1.2. Right? Pause, play, rewind, and redo the question if you need to.